Okay, so you've managed to work out that the formula is C2F6Cl2. So the question, oh, would you believe I've just gone and lost it, hang on. Okay, so the question, so what we can do here, we can work out the molecular mass of this compound, and I've just done it earlier, and when you work it out, the molecular compound, the relative molecular mass is 221. But if you want the actual mass, we know that chlorine comes in as an isotope, so it'll either be 35 or 37. So if we've got C2F6 where both the chlorines are 35, then the mass is going to be 220. But we may have an instance where one is a mass of 35 and the other one is a mass of 37 in this C2F6 molecule. So that's going to give us an MR of 222. Okay, because we're 2 mass units above. Sorry. And then we've got C2F6 where the chlorines are both 37. So the molecular mass of that is going to be 224. So we can work out those molecular masses. That's going to be great. Okay, the hard bit is this relative abundance, and it's statistics, I guess, and just applying what you did in maths. So here, what I'm going to do, I'm going to look at, we've got chlorine. I'm just going to put 2 chlorines here to represent the 2 chlorines in this compound. So the chlorines, in one of these compounds, we could have where they're both 35, or in the other compound where one of the chlorines is a chlorine 35, the other one is a 37, or even the first chlorine is a 37 and the second one is a 35, and then we could get a situation where both chlorines are chlorine 37. Okay, so we know that chlorine, as the 2 isotopes, is 35 to 37. You have a ratio of 3 chlorine 35s to every 1 chlorine of 37. So what chance have we got of getting a chlorine 35 in our molecule? Well, we've got 3 out of 4 chances. So that's 3 out of 4 chances. And same with the other one, 3 out of 4 chances. So wherever we see a 35, we've got 3 out of 4 chances of getting a chlorine 35. Whereas it's chlorine 37, we've only got 1 in 4. So we've got a 1 in 4 chance of getting a chlorine 37. Whoops, and a 1 in 4 chance there. So this is a 3 in 4 chance. And then for the last one, it's a 1 in 4 chance. Now, because these 2 are come together, and this is where my basic statistics, I'm very rubbish at expressing this, but the way that we work it out is it's those chances multiplied together. So 3/4 times 3/4 is 9/16. So out in 16 cases, we will get 9 of them will be like this. So with this one, it's 3/4 times 1/4. So that would be 3 out of 16. So in 16 cases, 3 of them will be this one. And then in this case, 1/4 times 3/4. So again, 3 of the 16 will be this type. And then with this one, 1/4 times 1/4 is 1/16. So only 1 out of 16 will be where you've got 37, 37. Now you've probably said, but these 2 are the same. They are the same. So we actually, what we do is 3 out of 16 are going to be where the first one is 35, the second one is 37. 3 out of 16 will be when the first one is 37 and the second one is 35. They're practically the same. So we do 3/16 plus 3/16. So that gives us 6 over 16. So 6 out of the 16 will be this. So in terms of what you draw on the mass spec, you've got a 220, 222 and a 224. Well, this one of the 16, this one is only, if we've got 16, this is only going to be 1 on the scale. This is going to be 6 times the size of this one, so where that's 1, that would go up to 6. And this one here is 9 times the scale, so this would go up to 9. So they come in a ratio of, I'll take you back to here, so we'll have 9 to 6 to 1. The ratio, the heights will be 9 to 6 to 1, so 9 to 6 to 1. So when you look at the mass spec, this will be 9 times the height of that one, and that will be 6 times the height of that one. So I hope that's helped, and I'm really sorry, I'm rubbish at describing how to do this. I can do it, I just don't know how to describe it, but I'm sure you did something like this in maths. Okay, so they're the answers.